Hey everyone, welcome to Notes today. This is lesson 5.3, which deals with triangle congruence, and specifically, we're going to learn about side angle side congruence. So we already know what congruent figures are. So those are figures that have the same size, same shape. We know what rigid motions are. That's where we don't change the size. We just change basically the location of where a shape is. So today, we're focusing on how can you prove triangles are congruent based on information given. The last lesson we talked about, you can prove that polygons are congruent if every single angle and every single side is paired up and congruent to a corresponding angle and side on the other polygon. Well, today we have this thing called side angle side, which says if two sides and an included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So if you look at my little red arrow here, I have a side, an included angle, and a side. They have our congruent marks, and they correspond with a side, an included angle, and another side. That means those two triangles are congruent. Now we say included, so it has to be the angle that's smashed between the two sides that are congruent. So we're going to do quite a few proofs today. So our first proof is right here. And we have a couple of givens. And so I'm going to start off, and I might not do this 100% precise, but we have our two givens. So the first given is that BD is perpendicular to AC and AD is congruent CD. So those are already marked in there for us. Now I want to prove at the end the triangles are congruent, and we're only going to do that with our side angle side theorem. So based on what I have to show a side, an angle, and a side. Right now I have a side. I sort of have an angle. I know when two lines are perpendicular, these are both right angles, but right angles don't mean that they're congruent. So what I would have to do is I would have to, on the second line here, oh, this was a given. My next part of the proof would have to say something like angle BDA, so angle BDA and angle, let's say BDC are right angles. And that would be definition of perpendicular lines. Now that we know that they are right angles, now what we can do is we can say that they are congruent to each other. So I can say that angle BDA is congruent to angle BDC, and the reason is our right angle congruence theorem. That theorem said that all right angles are congruent. So now I'm going to mark, I have a congruent angle here, I have a congruent angle here. So if we look, I have a side and an angle on both. Now I need another side. And one of the very popular things we're going to use is the reflexive property. I can say that BD, and I mark this different than some teachers. I like to put a little congruent mark here. I know there's only one of them, but if I separated the two triangles, triangles ADB and then CDB, I would want to have that side marked. And so right now I can say that BD is congruent to BD, and that's the reflexive property. Now I have side angle side, so now I can go and say that triangle ABD, so my last step, triangle ABD is congruent to triangle CBD, and that's from the side angle side. So number 5, side angle side. There's our proof. Now let's look at number 2. So number 2, this is a really quick proof. We have our givens. So I guess I'll just write those down. We have J N is congruent to MN and NK is congruent to NL. That's a given. And those are marked. Now, if I want to talk about side angle side, I have this two sides here, but I'm missing is the angle. So I want to find a way to prove that these two angles are congruent. I can prove that because they are vertical angles. So my next one is going to be the vertical angle theorem. And those angles are J and K. So angle J and K is congruent to angle M and L by the vertical angle theorem. Now we have side angle sides, so we can end with triangle J and K is congruent to triangle M and L because of side angle side. Let's go to the next one. All right, number 3, I'm not going to do a real proof for this, no real two-column proof, but it says use the given information to name two triangles that are congruent. Explain your reasoning. So I am going to be able to say that triangle, I'm going to highlight this, EPF is going to be congruent to HGP. So triangle EPF is congruent to triangle HPG. Now, the reason why is it says those two angles are congruent, and where I'm going to get my side angle side from, and we're going to do that with side angle side, but there's an in-between step here. Like, what is it before I can say side angle side? I know these sides are all congruent because all of those are radii from the center to the edge of a circle. And because of that, we can say that the radii or the radius are all congruent because a radius, well, all the points on a circle are equidistant to the center. So that's why this one would work. All right, let's do the next problem here. So this is a regular hexagon, and all we need to know is that regulars are given. A regular hexagon means that all sides and all angles are congruent. I want to find two triangles here that are congruent. And the big idea is I want to use an entire big angle, like the entire angle E is congruent to the big entire angle F, no like little ones. So I need to find some sides. And the only thing I know are the sides of this hexagon are congruent. So I'm going to highlight here triangle ACB. And if I look at that, the sides are congruent. And I know angle B is going to be congruent to all the other angles in this picture. Then I can look at triangle DBC. DBC has the two sides and an included angle. And they're the only triangles that we know for sure. So we can say triangle ABC is congruent to triangle, let's do DCB. Okay. There's only Yeah, it's just from side angle side. We don't have to do anything else on that one. And then this last question, it says we have two lines, PS and QR, that are parallel, and PS and QR are congruent. What do we still need to know to use side angle side? So I'm going to zoom in here and show you what we have. We have two lines that are parallel and they're congruent. And then if I use my reflexive property, so reflexive, I know that the side right here, the shared side, is also congruent. That means I have a side and a side on both. And now I need that included angle. So how do I prove that these two angles are congruent? That would be alternate interior angles because we have the two parallel lines cut by a transversal, and that means alternate interior angles are congruent. So there you go. If you have any questions, reach out, or we'll just see you in class for the next video.